Experiment 42, acid-base reactions. In this video we show an example of an acid-base reaction. We add calcium carbonate to an acidic solution and we see a reaction according to the chemical reaction, which is shown here. The result of adding solid calcium carbonate to an acid is that the calcium carbonate disappears. In our daily life we can use this reaction to undo the scaling from a coffee machine. The experiments are scheduled to be conducted with 100 ml of 0.1 m monoprotic acid solutions. Then the stoichiometric quantity of calcium carbonate amounts to 0.5 grams. The experimental setup consists of two beakers, the left one containing acetic acid solution and the right one is filled with a hydrochloric acid solution. After addition of the calcium carbonate, the reaction time is measured. The experiment will be conducted at room temperature and at 70 degrees Celsius. We expect the reaction rate in hydrochloric acid to be much higher than in acetic acid. We also expect the temperature to have a significant influence. The first experiment shows that with hydrochloric acid it takes about 20 seconds for the reaction to complete. With acetic acid, indeed, the reaction is slower, but the rate is still acceptable. The reaction time is about twice as long. After addition of more calcium carbonate, the mixture remains turbid, indicating that there is no more acid present. The second experiment is carried out at elevated temperature. The reaction looks more spectacular now. The rate, however, turns out not to be drastically higher than at room temperature. The observed bubbling can be ascribed to reduced solubility of carbon dioxide at higher temperatures. And next we see the reactions from a top view. From the experiments, it can be concluded that reaction rates with acetic acid solution are lower than with hydrochloric acid, the difference amounting roughly to a factor of 2. At elevated temperature, the reactions proceed somewhat faster. The use of strong acids for household purposes, however, brings about the danger of personal accidents and damage of the equipment. Reaction rates with weak acid are still acceptable, so we have to conclude that a weak acid appears to be the best choice to remove calcium carbonate deposits. However, longer reaction times may have to be reckoned with, because the powder used in the experiment has a large specific surface area compared to the lumps deposited on heat exchange surfaces in equipment like washing or coffee machines.